We've looked at adding graphs or adding data to existing graphs already. But what about updating data that's part of a graph? Like the additions, you need to be aware that things will work differently when the data is being tracked as the changes are being made, versus if it's disconnected and the DB context begins tracking the object state after the changes have been made. Let's first look at making changes to a graph of objects while EF Core is tracking them. Instead of actually saving the data and looking at the SQL, I'm going to just use the Change Tracker's debug view to show you how EF Core is interpreting the state of some graphs as I'm making changes. Here's a method where I've used include to query for a single author and then eager load that author's books. And I know I'm using an author that happens to have 2 books in the database. Then I drill into the first book in the collection, modify its base price, and call Change Tracker Detect Changes. Remember that Detect Changes causes the Change Tracker to update its knowledge of the state of all the objects that it's tracking. And I'm calling it directly since I'm not using Save Changes, which would otherwise have done that for me. After that, I'm capturing the Change Tracker's debug view into a variable. And when I run this method and look at the debug view, the state of that book is modified, and the author and the other book are unchanged. So since the context continued tracking those objects, it recognized exactly what had changed. Because this one-to-many relationship is using the default mappings where the book must have an author, I could also easily delete any of the books while the change tracker's in scope. I've added this line of code where I'm removing the book from the author's books property, not doing anything with Entity Framework Core. And looking at the change tracker when this is run, you can see that the state of that book is marked as deleted. We'll be looking more at removing related data a little later in this module. So as usual, things are pretty simple when the change tracker is in scope and watching what's happening with the objects. Now let's look at a scenario where the change tracker doesn't know about the object's history. Again, I'm retrieving that same graph and editing the book's price again. Next, I'm creating a second instance of the pub context to emulate that disconnected scenario. I'm using the book's dbset update method to tell this new context to start tracking that book from within the graph and mark it as modified. After that, we'll check the debug view again. When I run this method, look at this detail. Something really strange happened. All of the objects in the graph are marked as modified, not just that book. What happened is that the book is part of a graph, and when I called update, the update logic was applied to every object in the graph. And that is expected behavior for EF Core. Well, it's expected if you're aware of how EF Core works. The only time that update wouldn't get applied to every single object in the graph is for any items in the graph that are new and don't yet have a key value. In fact, objects with no key value, no matter if you use the add method, the update method, or the attach method, will always be marked added. That's a really good thing to be aware of. But otherwise, if you use the update method and you pass in a graph, you're telling it to update the graph. We do have other ways to start tracking objects and anything that's attached to them. For example, the dbset attach method. If I had used that instead of update, all of the objects in that graph would get tracked, but they'd be marked as unchanged, even the one that I modified, because the context has no idea that I modified it. I just said, hey, here are a bunch of objects. So using attach isn't going to help us either. So how do we get around the side effect of EF Core's behavior? It's not an easy coding task to separate the quote from that graph. But lucky for us, EF Core knows how to do that. We just have to use a different path. Instead of using the dbset add or update or remove method, you can use the dbcontext entry method, which gives you a lot more control. And if you're coming from EF6, take note because this behavior is different than it used to be. In EF Core, entry will focus specifically on the entry that you pass in. So I can pass the book object into the entry method and then use the entry's state property to set the state of that entry to modified, which is one of the entity state enums. In this case, I do want to call save changes because there's one more thing I want you to see. Now, when I'm using the entry method to track the book and set its state to modified, the change tracker is only tracking the book. Now let's see what happens when I call save changes. As expected, it only sends an update command to the database for the book. But notice that it's updating all of the columns except for book ID. And you learned about this earlier in the course when we used update on the authors. The update method has no indication of which property got updated, so it defaults to updating all of them, except for the key. There's a lot more that you can do with the DB context entry method, but for this fundamentals course, I'm going to leave it at that. Deleting objects from graphs is an interesting topic because there are a lot of players involved. You could be removing an object from an in-memory collection, marking it as deleted in the change tracker, or deleting it from the database. You've already learned that deletes were a little unnatural because the change tracker needs to be aware of an object in order to delete it. And you've just seen a quick example of removing an item from a collection while it's being tracked and seeing that EF-Core understands to delete that from the database. Let's look at that a bit more closely by first reviewing the default mapping. And I want to unveil the migration snapshot file, which will show us the current state of the mappings for this data model. And that will let me highlight a few interesting things about how that relationship is relayed to the database. And I'm going to jump down past where the book table is defined and its seed data is inserted to the explicit description of the relationship between author and book. The snapshot spells everything out, even if your code relies on conventions. And you should be familiar now with this has one with many pattern to describe the relationship, and the has foreign key method, which is noting that the author ID property represents the foreign key of the relationship. But there are two additional mappings here. The first is on delete with EF-Core's default behavior of cascade and the isRequired method. We've already talked about the isRequired default, but this delete behavior is new. Relational databases have a concept of cascade deletes, where when a parent is deleted from the database, all of its children are deleted as well. And that aligns with a business rule that says the dependent data cannot be orphaned. Therefore, if the parent is deleted, the dependent can no longer exist and the database will go ahead and delete it as well. And this mapping will force that constraint in the database schema as well. Here's the database's view of the constraint for that relationship. And in there is a property called delete rule, and its value is cascade. So the cascade delete is enforced by the database. If I retrieved an author, hold the context to remove it, and then called save changes, when that delete command hits the database will also delete any books that exist for that author, even if EF-Core didn't tell it to do that. But the cascade delete is also enforced by EF-Core. Let's say one of our authors signed a contract with another publisher. Now, in the real world, we wouldn't completely delete our history, but for the sake of you seeing this behavior, let's say we have a separate system for maintaining historical data. So I do want to eliminate this author and their books from the pub database. And just as an FYI, I manually entered some more authors and books into the database so that I could delete some things without losing my precious sample data. So in this method, I've retrieved that new author and all of their books. And as you learned earlier, next I can just call context authors remove and pass in that author object, which has the books attached. We'll first take a look at the debug view before saving. And notice that I didn't call detect changes before looking at the debug view. That's because I used an EF-Core method to delete the author, which causes the change tracker to fix up its state information. So detect changes already happened under the covers. So many little nuances, right? And there's still something interesting to see about the command sent to the database, so I will also call save changes. Looking at the state after I called authors.remove, you can see the cascade delete that EF-Core performed because not only is the author marked deleted, but so are both of the books. Then, after I call save changes, check out what's going on in the log. The delete commands for the books were sent first, Can you guess why? It's planning ahead for the database's cascade delete behavior. If it had started by deleting the author, then the database would have deleted the books because of the cascade delete. Then when the delete commands get sent to the database for the books, those would cause an error in the database because neither of those books exist anymore. So the order that EF-Core does this in is not random. Now, what if I had queried the author with only one book and then deleted the author? What about the other book that's still in the database? Well, EF-Core would first send a delete for the book that's in memory. The other book would stay in the books table. But then, when the author is deleted from the database performs the cascade deletes and gets rid of any other books for that author. So EF-Core and the database work as a team with cascade deletes. And just to wrap up the cascade delete topic, I want to clarify two questions that you might have. When we use the update command on a graph, it updated all the objects in the graph. Do you have to worry about that with the remove method? No, remove just doesn't work that way. You can remove a dependent in a graph. That won't impact the other objects in the graph. The other question is, what if you just want to delete a book and you don't have the graph? Well, that's the easiest scenario, and we've seen that before. You can retrieve just the book and then use context books remove for that single object. There are a few more things I want to make sure you're aware of about removing dependents from a relationship. What if you wanted to move a book from one author to another? The simplest path would be to retrieve the book and change its author ID. But you could also take a book that's attached to one author object and just attach it to another author object, either by moving it into the author's books collection or setting the book's author property to the new author object. EF-Core will recognize what happened, and it will update the book in the database with a new author ID. Everything we looked at so far was based on the default behavior where the relationship was required. But what if it was optional? In other words, you can have a book without an author. You did see early in this course how you could map that. In the case that you have set that relationship up to be optional, you could just change the book's author ID to null. If the book is attached to an author and being tracked, removing it from the author's books list would cause the change tracker to set the book's ID to null. And then when you save changes, that will get persisted correctly to the database, and the book will still exist. You've learned a lot about the default behavior of cascade deletes. As you dig further into your EF-Core education, you can use the tools you've learned, like debugging and looking at the logs, to explore variations in delete behavior, and also the effect of removing related data in disconnected scenarios. You will see a few examples of this when we use EF-Core in a web application further on in this course. Relationships are pretty important in our applications, and in this module, with a focus on our one-to-many relationship, you learned how to bring related data into memory along with the parent data that you're querying using the include method or projections. You can also get related data for an object that's already in memory, either doing that explicitly through the context with the load method, or that way that makes me a little nervous if it's used without truly understanding how it works, lazy loading. You also learned about filtering the queried data, or just using it to filter the base data that you're querying. While learning about adding, editing, and removing related data from graphs, you also saw that there are a lot of specific behaviors to be aware of, and those can also be affected by whether or not the change tracker is in scope as you're making those changes. For example, the add and update commands will affect all of the objects in a graph. Thankfully, if you do need to isolate individual objects from a graph in order to persist them, the DB context entry method knows how to do that for you. With all of these lessons in hand, you're ready to learn about other types of relationships. In the next module, we'll modify our model in response to some new business requirements, and then we'll be able to explore many-to-many relationships. Here's some resources that are relevant to this module and that I think you might find useful. I'm Julie Lerman, and thanks again for watching Entity Framework Course 6 Fundamentals.